Hi, I'd like to use this video to illustrate this very important, very interesting example on performing how to calculate or how to work it out graphically and analytically on the discrete time convolution. First, I'd like to use these particular functions to discuss with you. Right, this is x of n. X of n, as we can see that x of n is equal to alpha n u n. So that it is very important that we have to make sure that alpha must be less than 1 in order to converge. So what does it mean converge? Because what you can see that the function xn is alpha n u n. Right, if alpha is bigger than 1, then take for a simple example, there is 2, then we are going to have 2 to the power 1, 2 to the power 2, 2 to the power 3, and something like that, because this is un, alpha n un. So the function will basically, when n is equal to 0, is 0 to 1, then 2 to the power 1, then is equal to 2, 2 to the power 2, then we are going to 4, 2 to the power 3 is going to equal to h. So what we can see that it is going to be getting larger and larger. This is what we call diverge. So we don't want that. We want the function to be converging, to be quite honest. Converging, that means the function will be stable. We are going to talk about the stable later on. So in this case, when alpha is less than 1, so we are going to have some sort of thing like that. Start from here, when alpha is equal to maybe 0.9, then we start from here, 2 to the power 1, then 0.9, 0.9 to the power 1, that is 0.9, 0.9 to the power 2, when n is equal to 2, 99, that is 0.9 something, then 0.9 to the power 3, 0.9 to the power 4, 0.9 to the power 5. So when n is getting bigger and bigger, then we can see that it's tends to 0. That is what we like the function to be converged. Now, this is very important because without that, we actually cannot work out. The whole thing will become unstable. Now, coming back here, then this is the function, then another function. The impulse response is h of n. This is what h of n is about. When n is equal to 1, 2, 3, 4, 5. So h of n, that is what h of n is about. So it's going to be going to infinity all the time. Now, when we are going to do the convolution, then we try to rewrite the equation in such a way, right? I'm not going to repeat the fundamental why the equation is in such a way form, which we have gone through in the last half an hour. But the important thing is we are going to rewrite it in such a way form because the impulse function is u of n, so we can actually to rewrite that one into u n minus k. So yn, just like this one, will become summing all the things from k from minus infinity to positive infinity. Then x of k, then u n minus k. Mind me to be a little bit long-winded. In this particular case, right, n is not actually the variable. The variable is k, the variable is k. So actually we are just trying to find what n is going to be at the different sort of value. When we understand that, then we are going to do some interesting work. The interesting work is because this un is un minus k, that is, so we are going to flip the thing around. Important thing is for continuous, there's un, then there is u minus n. Okay. Now, so we have to be very good with that. Once when we are going to flip the thing in that way, this is what flipping the whole unit step function, discrete time in the left hand side because of this minus k. But the important thing is we have to focus on this particular n. Now, the next slide, we are going to discuss that. Right, so we understand that here, we are using this particular waveform here. This one is alpha k u k. Okay, so it decreases when k increases until it tends to 0 here. Now, the interesting thing we have to look at is this particular waveform here. Now, this one, it goes all the way from minus infinity until 0 here. Now, when we just coming back to the classical things here, okay, this one, okay, so this one is h, k, so this one will become, the red one is h minus k, because we just flip it to the left hand side here. So from minus infinity all the way until the 0 here. Now the interesting thing is when we look at this particular equation here, this is h minus 1 minus k. This is actually equal to h minus k plus 1 here. Now for this one, actually is equal to h minus k plus n here. So what is this so important and so interesting? We just look at this plus 1 and plus n here. When we are coming back to this conventional waveform here, okay, from minus infinity all the way to 0. So this one is h minus k. Now, so when we are going to shift it by plus 1, this plus 1 here. So what we actually means is we are going, still recall that we are going to move the y-axis into the right hand side here by 1. So by doing that, so the waveform will simply becomes something like that. Okay, so we don't have any 0 here. We don't have any 0 here. So this one become, that is h minus k plus 1. Similarly, when we are going talking about h minus k plus 2 here, then we are going to have, so nothing here and here, because we moved the axis here. So what we can see is when this one we expand it become h minus k minus 2 or minus k minus n. When n is less than 1, when n is less than or equal to 1, so we have all the 0 point here. So there won't be any overlapping with this particular waveform here, because when n is equal to 0 here, when n is equal to 0, we still have one overlap here. When n is equal to minus 1, this one becomes 0. When n is equal to minus 2, then the waveform is something like that. So we don't have overlapped. So that is the reason why, that is the reason why y and will all equal to 0 when n is less than 0. Then I'm going to use the next slide to further elaborate that. So once when we coming back here, so we have here, this is the reason why when n is equal to 0, so there one overlap. Mind you that this is 1, 1, 1, 1, 1 here. So we have alpha 0 here. So when n is equal to positive 1, not negative 1. Negative 1 will go to there. Positive 1 will come to here. So we have another overlap here. So yn will become alpha naught plus alpha 1. So when n is equal to 2, then we have one more overlapping here. So yn will become alpha naught plus alpha 1 plus alpha 2. And similarly, when n is equal to k, that is the case yn will equal to y naught plus alpha 1 plus alpha 2 plus dot 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 plus alpha k. Now, this is the task how we are going to sum this series in a more tidy way. We can basically write it in such a way yn is equal to summation, okay, k equal to 0 to n alpha k. That means from 0, alpha 1 all the way to alpha k. But still, how are we going to make this another tidy expression? Let's coming back here. We are concerning yn is equal to alpha 0 plus alpha 1 plus alpha 2 plus dot 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 plus alpha k. Try to recall that 1 over 1 minus a is equal to using long division. That is equal to 1 minus a become a, then plus a minus a square, then we have plus a square plus a cube. So all the way until a cube, then we have a k plus 1. So basically 1 over 1 minus a is equal to, okay, 1 plus a square plus a cube plus dot 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 plus ak plus ak plus 1 over 1 minus k. And this is the term that we don't want to. So basically, then what we can write, y plus a square plus dot 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 plus ak equal to 1 over 1 minus a minus ak minus 1 over 1 plus a. And this, in fact, is the expression that is what we are talking about. So this particular un is signified that 0, 0, 0 here. We all just start from when it is equal to n is equal to 0. So you go all the way, then you converge. Then what we can see is when alpha is equal to maybe half, then we are going to have y and will equal to 1 over 1 minus half, that is equal to 2. So when alpha is equal to 1, 3, that is equal to 1 minus 1, 3, that is 3 over 2. So what we can see is this waveform will converge to different value for different alpha. Okay, thank you.